go into the past, we'll find that the firing of ceramic material has occurred over many thousands of years ago. Around 1850, at the Sèvres Porcelain Company, there were two physicists who came up with a pyrometric device. This was a pyramid-type shape object made of a porcelain body, and they observed its behavior during the firing process. A few years later, a gentleman by the name of Dr. Hermann August Sager in Germany heard of this work, duplicated the work, and came up with a series of these compositions. He identified these as cones 1 through 36. In Zanesville, Ohio, there was a gentleman by the name of Edward Orton who had heard of this work in Germany and came up with his own series of these pyrometric devices, and he used these in a plant there in Zanesville making tile. Edward Orton found that they were very, very good in aiding in the control of the firing process. Pyrometric cones, as we call them today, actually came from the Greek word pyro, meaning fire, metric measurement, and this was identified by Sager in Germany. Sager called these kegels because to him they were shaped like a bowling pin. When Orton translated the word kegel from German into English, the word kegel was identified as cone, and that's how and why we call them cones today. So a pyrometric cone basically comes from the Greek word pyro, fire, metric, measure, the German kegel, cone, pyrometric cone. Edward Orton Jr. was the son of the first president of the Ohio State University. In 1894, Edward Orton was working in a tile company in Zanesville, Ohio, was trying to promote better firing techniques. And following his interest, he went to the state of Ohio and got a grant to initiate a ceramic department at OSU. The gentleman also founded the American Ceramic Society. He was the dean of the College of Engineering. He was a state geologist. In 1932, upon his death, he had in his will created a nonprofit organization that we refer to as the Orton Ceramic Foundation. When Dr. Sager developed his original cone range, it was from 1 through 36. Dr. Orton duplicated this. However, in the ceramic industry in the United States, there was a need for compositions less than cone 1. And this was basically in the brick industry. So Dr. Orton then developed a series of compositions that would deform less than cone 1. To come up with a identification less than 1, they put a 0 in front of these, and that's why we have cones 022 through 01 today, compositions that deform less than cone 1.